Hey everybody, this is Larry. This is me doing week 4 of the weekly premium challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's prompt. And yes, my hands are, I'm excited because this is a prompt that we haven't solved yet. That's why I'm excited. It's a premium prompt, 683 KMT slots. Alright, let's get to it then. We have n bulbs in a row, numbered from 1 to n. Initially, all the bulbs are turned off. We turn on exactly one bulb every day until all bulbs are turned on after n days. Is this the you're given in bulbs of length n where bulbs of I is equal to x means that on the I plus 1 day we turn on the bulb at position x where I is 0. And what? Who does this? Who does two things in different indexes? Who hurt you? Who wrote this problem? I don't know. Okay. In any case, if I get an off by 1, I'm taking no responsibility. That's my excuse. I'm sticking to it because these things are silly. Alright, given an integer k, return the minimum day number such that there exists 2 turned on bulbs that have exactly k bulbs between them that are all turned off. If there isn't such a day, return -1. Okay, so the at most was it 20,000? Bulbs are permutation from 1 to n. So okay, so basically we just want 2 bulbs in which there are exactly k between them, right? I think there are a couple of ways to do this, but I don't think it's that bad. I think it's just simulation, right? Because the idea is that it's simulation, but I think it's based on an idea. I don't know, just also to be clear, if I get it wrong, my bad. But my idea is that it's a simulation, and the idea is that, okay, well, given a state of the world, when you turn on one bulb, what happens, right? I think also, just to be clear, you can also maybe binary search, because if you binary search, it'll be n log n anyways, and that'll be fine because you just go through the array, you simulate, and you do a check. That's n log n, because there are n different at most things that you search for log n, so that's fine. That's a reasonable solution, by the way. But I think you can actually do a linear way. Because not linear, but in the search is linear. It may take a little bit more, and the reason is because given the state of the world, you can only change one bulb at a time. Well, that's what they tell you. But changing that bulb does not change anything globally, right? It only changes something locally. Meaning that, for example, if k is equal to 1 or 0 or whatever, something small, you don't it doesn't matter if there's a bulb 20 steps away. You only look at one bulb, right? So one away, because that's the only thing that matters. And it doesn't mean that you have to change. I guess it means that you have to check the next 20, but in a very precise way, right? Yeah, and I think that's it. I think honestly, maybe the binary search implementation is easier to write because it's just simulation and log n binary search. But I do want to play around a little bit today, so I am going to use the sorted the other implementation of just to challenge myself a little bit. Okay, then you have n is equal to length of bulbs, and then for I in range of n. So then now, these are only turned on, right? You don't turn off. Yeah, they're all only turning on for this one, so it's not a toggle. So that's even easier, I think, right? So you have a sorted list is equal to sorted list. And then here we want to add I, right? And then now, because we added this, we just search for the index. I think this is the maybe that's right. Let me run it. I forget the naming. Okay, no, that's fine. And this has to exist because you just added it, right? So then now, if index -1, index -1, if this number yeah, so the previous number with if the current, oh, and also this is not add I, by the way, this is both sub I, so I messed up already, but the idea is still right. So if x minus this, because we're going to the smaller one, if this is equal to k, then we're done, right? Or k, because k exactly that are off, so this is actually technically k minus 1. If this is the case, then we're done. We return I, right? It's either I or I minus 1 or something. So that's basically it. And if index plus 1 is less than length of SL, then same thing, right? If SL index plus 1 minus x is equal to k minus 1, then we return, wait, is it k minus 1 or k? I don't know why I wrote k minus 1. It should be k plus 1, right? Because the k in between, so the number is going to be k plus, oh, this one is, no, this is k plus 1. I don't know why I wrote k minus 1. I think I meant to, I think what I meant to write was something like if x minus k is equal to SL index minus 1. I think I meant to write this in my head, but then I kind of just, I don't know. And of course this you can, I don't know. Alright, we'll just run it. I think it's one or the other. Apparently I'm really well. Expected 2. Where we return the minimum day number. I have to double check the day number and what does it mean. Well, this one's fine, but like 1, I output 1, but obviously the answer is not 1 on the second day. So okay, so I think this is this plus 1. Okay, because obviously like 1 doesn't make sense because unless it's 0 index, because you can, this would never be true for any number you go to 1, right? So okay, YOLO submit. All right, not that bad. I mean, a little bit on the slow side. I think as an up south, I think this is fine. This is interesting. It is what we did, right? But I think it's an up south, or maybe that this is the way you did it to begin with. If you did it one way or the other, try to do it the other way. I think that's up south. So if you did it this way, do the binary search. If you did the binary search, try doing it this way and see what happens. That's it. That's all I have with this one. Let me know what you think. Thanks for watching. Oh yeah, complexity, and they're both the same complexity. I just want to say because this makes it log n, and I think this is also log n. But if not, then maybe these are. So it's gonna be n log n is my point either way. Just even if this is true, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye bye.